Hello, my friends. Welcome to part 12. That's right. This is the last part to my 12-part video series on Eastern hunter-gatherers from Sidel'kino village in this region right here in central Russia. Make sure you watch the previous 11 videos that I filmed on Eastern hunter-gatherers from this village. Every video is a separate sample. So there is 12 samples, 12 videos, 12 Eastern hunter-gatherers from Sidel'kino. Make sure you check out all these videos. So this individual is a female. She lived 61 centuries before the Common Era, so 81 centuries before present, a long time ago, Middle Mesolithic period. In terms of the deeper admixtures, she seems to be a mixture of mostly ancient North Eurasians, represented in this G25 model as Afontava 3. Then a little bit of Western hunter-gatherer admixture. You can see 30% Western hunter-gatherer admixture, and a teeny bit, a little bit of Caucasian hunter-gatherer admixture as well. 2% Georgian hunter-gatherer, Georgian Caucasus hunter-gatherer admixture at the very bottom here. So mostly ancient North Eurasian, a little bit of Western hunter-gatherer, and a tiny bit of Caucasian hunter-gatherer admixture on top of it. Now, in terms of her mitochondrial lineage is U4A, very common mitochondrial lineage for various European hunter-gatherers, and actually very common lineage for modern Europeans as well. Okay, let's go ahead and check what she scores for Nasha code calculator, what she looks like, what her phenotype is, and it looks like for phenotype, she's quite dark, so it looks like she has dark brown eyes. She's scoring 65% odds for dark brown eye color. 33.5% odds for brown eye color, and she definitely doesn't have hazel or green or blue eyes. So that's completely out of the picture. Green, hazel, or blue eyes, that's completely, almost completely impossible for her. If you add up those percentages together, they add up to less than 1%. So green, hazel, or blue eye color is pretty much completely impossible for her to have. When it comes to hair color likelihood, she definitely has black hair. Once again, any other hair color besides black is very much completely impossible for her to have. So she definitely has black hair. Most likely she has dark brown eyes, although brown eyes are also possible at 33.5% likelihood, but most likely she has dark brown eyes, black hair, and most likely she also has light brown skin. So based on this description, she looks quite, you would say, South Asian, maybe North African or South Asian, maybe even East African. Let's find out what her hair texture is. So her hair texture looks like is curly, although hair texture looks like isn't determined very well. It's not a very high quality file, so because of that, the hair texture isn't being determined very precisely. For the nose shape also isn't being determined very precisely, so it's kind of evenly split between Greek and snub. Let's go ahead and check what she scores for the coloring related variants. So she's heterozygous here, which means with snipper free she would probably get predicted as having hazel or brown eyes. She does not have any light color variants in BH2, blue haplotype 2. She does not have blue haplotype 2, nor does she have blue haplotype 1. So she would score brown eyes with both Y-sec and snipper 3 because of that. She also does not have blue haplotype 3. So she's very dark, very dark in terms of pigmentation. Okay, she does not have any light color variants in this variation of SLC 45A2, so she's very dark, much darker than pretty much any European today. Compared to Europeans who live in Europe today, she is like she's like extremely dark. There is no European in Europe who has the kind of pigmentation she does. Even in Greece, people are much lighter than her. Her pigmentation is maybe more comparable to people in India or in maybe in Saudi Arabia than in Europe. So she's very dark. That's the point I'm trying to convey to you. And she does not have any light color variants in MC1R, no ginger variants in MC1R. So this is what people don't understand. A lot of people have this conception that European hunter-gatherers must be quite light in pigmentation, and people make these phenotype predictions or phenotype reconstructions where they make them blonde or blue-eyed. Why should they be blonde and blue-eyed when they live in the Mesolithic period? Why should they be looking like modern Europeans when they aren't modern Europeans? People in the Mesolithic don't look the same as people today. There's been a lot of changes, a lot of evolution between the Mesolithic and now. So obviously they aren't supposed to look the same way as their descendants do today. People change, and people got a lot lighter over time. And people today, Europeans today, don't look the same as our ancestors looked in the Mesolithic. We are a lot lighter now than our ancestors looked in the Mesolithic. And I have seen this because I have looked at pretty much every single group in the Mesolithic that existed. They are all very dark. They're all very, very dark. And in the phenotype oracle, we see the phenotypes that she's closest to don't look like modern Europeans whatsoever. You can see the closest phenotypes to her. Well, I mean, it's very much something you could expect when she's scoring light brown skin and black hair and dark brown eyes. That exactly matches the phenotypes you see that she's scoring with the phenotype oracle. That pretty much matches the phenotypes that she scores with the phenotype oracle. That's the second closest phenotype, and that's the third closest phenotype. Obviously, not very European looking. But in terms of the not very modern European looking, right? Modern Europeans don't look like this, but Europeans in the Mesolithic period, sure. In the Mesolithic period, a lot of Europeans look like this. Sure, of course. Especially ancient North Eurasians. That's a very common phenotype for ancient North Eurasians. Very, very common. But for modern Europeans, no, not really. Not really. And for the mixture, for the two-way mixture, the closest mixture is a mixture of 50% this, which is, I guess, a stranded phenotype, plus this, which is, I guess, a Mediterranean phenotype. The second closest mixture is a mixture of 50% this, which is a South Asian phenotype, plus 50% stranded. And the third closest mixture is a mixture of this plus stranded, plus this, which is, I guess, Saudi Arabian. So I was spot on. I mean, it does look South, maybe Indian or South Saudi Arabian, something like that, because of the pigmentation, right? Dark brown eyes and black hair and light brown skin. It does sort of look like something brown, and because of that, she's scoring all these brown phenotypes in the phenotype oracle. Okay, that makes sense. Let's close that. Let's see what she scores for the biomarkers. Alright, for the biomarkers, she's got a below average odds for vitamin D, below average levels of vitamin D. She's got a below average level of LDL cholesterol. Actually, hold on. I did not check something. I wanted to check something that I usually do. She doesn't score any East Asian or like Oceanian or like Australoid or East Eurasian stuff for the phenotype oracle, so she probably does not have any East Eurasian variants in EDAR, but I still want to check that. I still want to check it, so let's check it right now. So she does have European genotype in EDAR. That's what I was expecting, right? And she has a genotype for longer midface length, larger nose size, and nose pointing up, and lower odds of missing teeth for the facial morphology panel. Okay. Pretty much what I would expect. Now let's return to biomarkers and see what she scores for that. So looks like she's got a below average level of glucose, which is really good to see. A average level of hemoglobin, which is good to see. A average blood pressure, good to see. Below average level of iron in the blood, so she probably does not have hemochromatosis variants, really good to see. A average level of sex hormone binding globulin, really good to see. Below average level of red blood cell count in blood, typical stuff. Below average number of base pairs for telomere length, so she's got predisposition to a shorter lifespan. Very, very interesting. It's actually a little bit extreme, a little bit of an extreme genotype, but it's whatever. And higher height, higher predisposition to taller height. So she's quite predisposed to being taller, which is very interesting. All right, let's close that and let's go over the polygenic risk scores. I'm not going to go over stuff that is average. I'm only going to go over stuff that is very significantly below average or above average. So she's got a very below average odds for kidney stones, below average odds for hemoglobin E disease. She's got a very below average odds for migraine, high score for lupus. She's got a, let's see, very high score for exfoliation glaucoma. Let's look that up in the file. So she does have a genotype for much higher odds for exfoliation glaucoma. That makes sense. That totally makes sense. She has very low odds for polycystic ovary syndrome, which is really good. So she doesn't have this bearded lady syndrome. Very good. She has very high odds for age-related macular degeneration. She has averages for slightly above averages for rheumatoid arthritis. She has high odds for Tourette's. She has high odds for epilepsy. She has higher odds for asthma. She has higher odds for vitiligo. Okay, so for vitiligo, she probably does have risk variants in the HLA gene. Okay, let's see what else. She has lower odds for stroke. She has higher than average odds for male pattern hair loss. Okay, now when it comes to male pattern hair loss, it is typical for West Eurasians to score higher for that, so it's pretty much a typical score for her, even maybe a little bit below average for West Eurasians. Let's see what else. She's got spot on average score for unipolar depression. She's got lower than average score for bipolar type 1, and she's got lower than average score for schizophrenia. She's got high score for type 2 and type 1 diabetes, so she's got some predisposition to both type 2 and type 1 diabetes. She's got high score for Alzheimer's, and she's got below average score for multiple sclerosis. All right. Okay, for breast cancer, she's got 1 risk variant out of 8, which is very typical. It's not marked as important, so that's quite good. For testicular cancer, no risk variance, really good to see. For celiac disease, no risk variance. For GSS, no risk variance. For Crohn's disease, none of them are marked as important, so that's really good to see. For Riefenstein's, no risk variance. For Parkinson's, no risk variance. Gilbert syndrome, 2 common risk variance. All right, that's pretty typical. Basal cell carcinoma, no risk variance. I'm just going to scan through this and see. I don't see any uncommon risk variance for any of this, so that's pretty good. That is pretty good. So the only things that we really have to watch out for are the risk scores for type 2 and type 1, especially type 1 diabetes. But type 1 diabetes, it is influenced by the HLA factor, the HLA gene panel. So let's look up the HLA gene panel real quick. HLA gene. Yes, okay, so for the HLA gene panel, the result is it's actually quite bad. So she's scoring intermediate or slightly higher odds for autoimmune disease on the HLA gene panel, so that definitely affects the score for the type 1 diabetes risk score. So type 1 diabetes risk score is probably like the raw score without the effect that the HLA gene panel has on it. It's probably a little bit lower than this when you take that into account. Lupus is affected by that as well, and asthma is as well. So when you take that into account, the raw score for asthma and lupus is probably a little bit lower than this. Yeah, lupus as well. It's probably a little bit lower than what it says here on the screen. Okay. So exfoliation glaucoma is a risk. Then also age-related macular degeneration is a little bit of a risk. And I guess type 2 diabetes is also a little bit of a risk. Let's close that and let's go through the monogenic traits and see what we find here. So for warrior versus warrior, she's scoring intermediate phenotype, so intermediate levels of dopamine and intermediate ability to tolerate stress. This is actually kind of an outlier result for a Eastern hunter-gatherer, but she's actually not that much, not so much of an outlier, because she's almost scoring warrior. She's almost a warrior. It's just 3 percentage points away from scoring warrior actually, but so she's definitely predisposed more to being a warrior than a warrior. But nonetheless, the largest thing she scores is still intermediate. But anyway, out of these 12 samples that I've looked at so far, only 2 samples scored largest percentage for intermediate, and the other 10 scored largest percentage for warrior. So that's definitely very interesting. There is definitely a ethnic correlation between being an Eastern hunter-gatherer and having warrior phenotype for COMT, MAOA, and MAOB genes. And in case you don't know what warrior versus warrior has to do with, I talk about that in every video, but a lot of people probably don't. Maybe you haven't watched the other 11 videos. Essentially, warrior phenotype has to do with having higher activity of the COMT and MAOA enzymes. And these are the enzymes that break down dopamine and norepinephrine in your system, in your central nervous system. And having higher activity of these enzymes essentially means you have lower amount of dopamine and norepinephrine at all times. And that leads to some problems with attention and motivation. But however, in conditions where there is a lot of stress, conditions where you're performing under stress, you have higher natural production of dopamine and norepinephrine, and you reach these optimal levels for functioning, and you're able to perform really well under stressful conditions. So if you're a warrior, you're able to perform really well in stressful conditions. But if you're a warrior, you have naturally lower activity of these COMT and MAOA enzymes, and because of that, you have higher amount of these of these norepinephrine and dopamine neurotransmitters at all times, which means that when there is no stress, when there is no stressful conditions, you have higher amount of dopamine and norepinephrine in your central nervous system, and you are able to perform really well when there is no stress. However, when you are placed in a stressful condition, you have too much of these neurotransmitters in your system, and you aren't able to function as well. And therefore, it says lower stress resilience. So this is a warrior phenotype, and the warrior phenotype is a very European phenotype to have. So Europeans tend to be warriors as a general rule, and non-Europeans tend to be warriors as a general rule. When it comes to DRD2, she has a predisposition to less dopamine D2 receptor sites in the brain, so she has some protection from such conditions as schizophrenia and bipolar. She does have some predisposition to such conditions as ADHD. Okay. Okay. Let's see what else. For 5-HT and serotonin, looks like she has predisposition to lower levels of 5-HT and serotonin, which means she has some predisposition to such conditions as anxiety and depression. All right. For autism risk score, it looks like she has predisposition to higher odds of autism. Okay. For lactose persistence, looks like she has a predisposition to intermediate or higher odds for lactose intolerance. Which means she's probably not lactose intolerant. Let's go through these genotypes and see does she have any variants for European lactose persistence. Looks like she does not have any derived variants for European lactose persistence or the Arab lactose persistence variants. So she, yeah, out of the 6 variations, out of the 6 variants, she does not carry any variants for lactose persistence. So pretty much she's definitely, if she does carry any variants for lactose persistence, it's probably not any of the main ones. Okay, for OXTR and empathy gene, it looks like she has a predisposition to higher level of empathy based on this 1SNP. So it's not very reliable. I wish there was more information in this file. For diabetes, remember she was scoring for higher for both type 1 and type 2 diabetes. So okay, she got a genotype for increased risk of type 1 diabetes, but she got all these genotypes that leads to a decreased risk of type 2 and type 1 diabetes, which is very interesting. Definitely very interesting. She's not a carrier for the C282Y hemochromatosis mutation. For Alzheimer's, she was scoring higher for odds for Alzheimer's because of the genotype mostly, which leads to an increased risk of Alzheimer's. But she does not carry risk for Alzheimer's in APOE, which is really good. She does not carry risk variants for multiple sclerosis in the HLA gene, which is really good as well. For cardiovascular disease panel, she has lower odds of cardiovascular issues, which is really good as well. For vitiligo panel, looks like she has 2 risk variants of vitiligo on both the HLA variations that have to do with vitiligo. So she's quite cooked when it comes to vitiligo risk variants. And this also contributed big time to the HLA gene panel. Okay. She's got impaired muscle performance, likely endurance athlete rather than strength for power athlete, and she's got no fat gene variants in FTOs. Well, I'm going to talk about that a little bit later when we get to the fat obesity panel. Okay, for the MCHFR panel, she's got lower odds of various health issues. Really good to see. She's got slightly higher than average odds for alcoholism, so slight predisposition to alcoholism. Okay, for rare diseases and traits panel, let's go through that. Does she have any predisposition to any rare conditions? She has this genotype which leads to 20 times increased risk of ankylosing spondylitis, which is a very rare condition. She has a genotype that leads to 5 times increased risk of rheumatoid arthritis. I remember she was scoring higher for rheumatoid arthritis, so that makes sense. And that's pretty much it. Okay. She has no risk variants for Canavan syndrome. She has no risk variants for HIV and AIDS panel here. For CBS panel, she has a genotype for slightly decreased homocysteine levels, but we remember she had a healthy genotype in the MCHFR gene that also has to do with the homocysteine panel. So that contributed to the score, and she's scoring intermediate or lower levels of homocysteine, which is really good. So because of well, there's also this genotype which leads to higher levels of plasma homocysteine, but it's not enough to really contribute to the score in a significant way. So because of that, because of the good genotype in MTHFR, she's scoring lower levels of homocysteine, and also she doesn't have any risk variance for homocystinuria in CBS gene. So she's quite good. She's got a really healthy genotype here for the homocystinuria panel. Okay, no risk variance for muscular dystrophy myopathies, really good to see. No risk variance for color blindness in OPN1SW. And for FTO gene panel, she's got predisposition to lower or intermediate odds of obesity, actually lower odds of obesity at 50%. So based on these 1, 2, 3, 4 SNPs, she's got predisposition to lower odds of obesity. Really good to see. Based on this one SNP, she's got slightly above average odds for syncope. And for biotraits panel, looks like she's got 2 copies of the hunter-gatherer CLTCL1 gene variant, which leads to a reduced ability to process carbs and sugars. Okay, so she's a hunter-gatherer, and she's got 2 copies of the quote-unquote hunter-gatherer CLTCL1 gene variant. Very, very ironic. Alright, now finally for the blood group panel, she has blood type O, very common blood type for humans worldwide. And I think I noticed that out of these Eastern hunter-gatherers from Sidel'kino, aside from one person, all of them had blood type O. So it looks like blood type O is also a very common blood type for Eastern hunter-gatherers from Sidel'kino. Might be a very Eastern hunter-gatherer thing to have blood type O. Well, anyway, thanks for watching my video until the very end. I sure hoping you enjoyed watching this content. Make sure you leave a like and subscribe in case this is the first video you watch. Just leave a like in case you are already subscribed. And read the description of the video. In the description of the video, you will find the link to download this raw DNA file in 23andMe format. And also in the description of this video, you will find the links to buy my trait predictor executable, which is the tool that I use to generate these reports for the raw DNA files that I analyze. And also you will be able to purchase a report for $4 for a DNA file like my heritage 23andMe ancestry DNA file. Only $4, and it's gonna look something like this, something like what I've shown here, but a little bit more detailed, a little bit better, because these files that I analyze are usually a little bit incomplete. They lack some information that a commercial DNA file usually has. So if you buy it for $4, you'll get some. Well, just look at my official website. I have a website where I publish results from like my heritage 23andMe ancestry. So look at my official website what a typical like commercial DNA file result looks like, and you'll see what it looks like. Anyway, thanks for watching until the very end. Leave a like and subscribe, and goodbye.